So I have 6 different examples here. In these examples, we're going to do a few things. First thing we're going to do is decide if the two triangles are similar to each other. If they are, how are they similar? Which one of our reasons would we use? Would we use side, angle, side, 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 or would we use angle, angle that we learned about yesterday? And then finally, if they are similar, we want to name them. And remember, the names of similar triangles tell us something about those triangles. The way the letters are listed tells us the pairings of which angles match up with which angles, which sides match up with which sides. So we need to be careful when we name them that we're naming them according to that correspondence. So the first thing we need to determine is, are they similar? Well, in that first example, if they are similar, which of the 3 reasons would we use? What do we know about the triangles?
Sides.
All of the sides. We don't know any angles. We know all the sides. So if it works, it's going to work by a side, side, side. We don't know if it works, but if it works, that's how it's going to work, because that's what we know is all the sides. So to tell if it works, what we're going to do is set up the ratios of what should be the matching sides. Small sides should match with small sides. Medium with medium, big with big. So we're going to set up 3 fractions where we look at small in one triangle to small in the other triangle, medium to medium, and large to large. If those all reduce to the same value, then they are all in proportion with each other, or they have the same scale factor, so that would mean that we have similar triangles. So 10 over 16, what does that reduce to? 5 over 8. They both reduce by 2 to give 5 over 8. What about 15 over 24?
Do you want it to be 32, not
3/8.
Yes, thank you. I wrote down the wrong number on that last one there. What does the middle one reduce to?
3/8.
What does it reduce by? What do they have in common?
5/8. Wait, what is the numbers are they?
15 and 24. The middle fraction there. They both divide by 3 to give 5 over 8. What about 20 and 32? What do they both divide by? 4 to give 5 over 8. They all reduce to 5 over 8. So that means that these sides all had that same scale factor of 5 to 8. So these two triangles are, in fact, similar to each other. So now we need to name them. When we name a triangle, and I'm just going to write right on top of these triangles because I didn't really leave myself any room here, I'm going to name one of the triangles whatever I want. We can name that first triangle anything. The second triangle, though, we need to be careful that we are matching the right letters. So H, when I look at angle H, it is between the small side and the medium side. H touches the 10 and the 15, so it's touching the small and the medium. Which angle in the second triangle touches the small and the medium? R. So that means those match. G is touching the medium and the large. So what letter is touching medium and large in the next one? S, and then the only letter we haven't used is X, so it must come next. Okay, so we need to make sure that we're picking the right letters for that second name according to how we did the first name. The first name could be anything. Put them in any order, doesn't matter. But once we've done that, we need to make sure that we're matching up the letters for the second name by what's touching the same size, large, etc. Okay? Questions? So go ahead and work on the next 5 of these. A few things to do for each. Decide if they are similar, what would our reason be? Decide if they are similar, and if they are similar, name them. Okay, so go ahead and work on these. The top right green one there, we know a couple angles. So if this is going to work, which one of our reasons would it be? Angle, angle. Okay, we don't know any sides, so we can't do a side, 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 or a side, angle, side. but we do know a couple angles. Yesterday we learned about angle, angle. That means that two angles would need to be equal. We can see they both have a 70, so it looks like we've got a good start there. But the other two don't match. But we are missing an angle in each. So let's figure those out. What's angle C?
70.
70 when we subtract from 180. And angle J?
50.
50. So we only have one angle that matches. That's not good enough. So these don't work. For the next one, the middle row green one, if they work, what would our reason be? Side, angle, side. So then we would have to know an angle. What angle do we know? We've got some vertical angles. So then we have two sides and we have the angle between those sides. So if these work, they're going to work by a side, angle, side. So now we need to see, do they work? If they're going to work, then the sides need to be in proportion. To tell if they are in the same proportion, we need to compare small of one with small of the other, and bigger of one with bigger of the other. We could cross multiply and see if we get the same values, and if you get something true, that would work. Or we can reduce them and see if they reduce to the same thing, and that would work as well. What do they reduce to? They both reduce to 4 over 3. If you did it upside down and you got 3 over 4, that's fine. It doesn't matter which way we compare as long as we're consistent. Okay? So I chose to put the left triangle on top and the right triangle on bottom. If you did the other way, that's fine. But we get the same ratio. So that means they are in proportion, which means these are similar triangles. So we can name the first one whatever we want. So I'll call it RQS. Now we need to be careful with the second name. Angle R matches with the bigger side and the side we don't know. So which one matches with the bigger side and the side we don't know? U. Angle Q, well, that's the one I don't have marked, so it should probably match with the one I don't have marked. And S should match with itself because that's where our vertical angles are. For the next one, middle red, if they work, what would our reason be? Side, angle, side. For side, angle, side, we need two sides and the angle between the sides. Is that what we have?
Yes.
What angle is between the sides marked 8 and 12? What angle is between the sides marked 8 and 12? W is the one that's between. And Z would be the one that's between. And we don't know if those are equal. We do know the angles at X are equal, but that doesn't work because it's not the angle between. We need the angle between. So these could be, but we don't have enough information to go off of. They might work, but we cannot be guaranteed that they work based on what we know because we don't know the right angle. We need to know the angle that's between the sides that we know. For the red one in the bottom row, if they work, what would the reason be? Side, angle, side. What angle do we know? N. At N, we really have two right angles there. So if they work, they're going to work by a side, angle, side. So now we need to see, do they work? So do the ratios match up? So we need to do smaller of one triangle with smaller of the other triangle. Bigger of one triangle with bigger of the other triangle. That 15 is in both triangles. It's the bigger one in one triangle and the smaller one in the other triangle. What does 9 over 15 reduce to? 3 over 5. Does 15 over 25 also reduce to 3 over 5? Yes, it does. So that means these two triangles are similar, which means now we need to name them. I'm going to call the first one PLN. Then angle P is the one that matches, or it's between the side that we don't know and the big side. So in the second one, what is next to the bigger side and the side we don't know? L. L in the first triangle is next to the side we don't know in the small one? What's next to the side we don't know in small one? A. And then N should match with itself because those are the right angles. For the last one, if they work, what would the reason be? Side, 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 because all we know about this thing is sides. So now we need to see, does it work? So we need to set up small of one triangle with small of the next triangle. Medium of the first triangle with medium of the second triangle. Large of the first triangle with large of the second triangle.
How do you know which triangle is going to be first and second?
You can choose, as long as you do it the same way every time. So I did kind of the top triangle, then the bottom triangle. If you do the bottom, then the top, that's fine. Just do it the same every time. 16 over 24, what does that reduce to?
No.
What do they reduce by? What goes into 16 and 24?
6.
4.
4 does, but there's something bigger. 8 goes in there to make 2 over 3. What about 20 and 30?
2 over 3.
2 over 3 when we divide by 10. What about 24 and 36? 2 over 3 when we divide by 12. So they are all the same. So these are similar. Now we need to name them. I'm going to call the first one DAC. So then I need to think about what angle is going to match with D. D is between the small side and the medium side. What's between small and medium in the other triangle? A is between small and medium there. So the next I've got A listed. A is between medium and large. What's between medium and large? B. And then we must have C, because that's the only other letter left. Any questions on naming them? It's pretty tricky coming up with the correct order. All right, we have one more thing to look at. You're going to have a few proofs, couple proofs, 2 proofs. So let's look at a proof. Is the given. So we're given 3 fractions all set equal to each other. What does that mean? Why are the 2 triangles similar? What does that mean when we're setting up a segment over a segment equals a segment over a segment? What are we saying then about those sides? They're all proportionate to each other. So all 3 sets of sides are proportionate to each other. So then we can say our triangles are similar. DEF is similar to, now again we need to be careful here when we name these. I'm going to use tally marks on the pictures to denote which are matching with which. Usually we just do that to show congruence, but I'm trying to name here, so I'm going to show what matches with what. So according to the fractions, DE matches with GH. DF matches with GI, and EF matches with HI. So it looks like they arranged these pictures nicely, and what looks like it's supposed to match does match. So DEF should match with GHI. Okay, they didn't rotate or flip or do anything weird with the triangles. They just let them both sit the way they wanted to. Now, why are they similar? Which one of our 3 similarity reasons works for this? Side, side, side. That's what we know about. We know all the sides are in proportion. We don't know anything about the angles. But we were asked to prove something about the angles. What does similarity mean? When we define similarity, what did it mean about the 2 figures? All the angles are congruent and all the sides are in proportion. So they are in proportion makes it similar. And now because they are similar, the matching angles should be congruent. So we can go to the congruent angles we want to prove by the definition of similarity. That's what it means to be similar, is that the sides will be in proportion and the angles will be congruent. Okay?